the structural distress has been occurred, that time we will go into this for the ground penetrating radar, and it's an expensive one. And as well as the well-known, that is a bump integrator, as well as the RRTM, that is a roughness, like in that is, I can say, the road roughness index measuring, like a response type road response roughness measuring instrument. So it will measure both the bump integrator as well as this RTRRM will measure only the IRI value. There is a international road roughness index only it will going to measure. Okay. So next, that might be in mm per kilometer or meter per kilometer, like that it will going to measure. And again, another one is a video survey van. That is a taking a video survey van. We're going to scan throughout the like road stretch, and again it's a costly as well as a limited scalability will be there for this method. And another one is the falling weight deflectometer. Again, while connecting the falling weight deflectometer, we are going to fix a series of geophones, and at the one point we're going to drop the weight. So because of this weight, what are the waves or the frequency which are going to observe by those geophones? Based on that, we're going to judge the what is the type, what is the condition of the existing pavement. Again, it's a point-based loading. Okay, so again, for this, while conducting this evaluation, we have to close the lane closure will be there, as well as it will not measure the any the top surface distresses information. So these are the like different methods, traditional methods, existing traditional methods we have to evaluate the existing pavement surfaces. Okay, next we'll move to the advanced. There is a AI based inspection methods. I can say that there are different methods out there. I can say I have listed out here. The CNN based classification. So what do you mean by this CNN classification? I can say that it's like a CNN is a I can take an example of it's a like a eye, and for a human being it works like a eye and a brain. Okay, it will detect the first, like the eye, how the eye will going to detect the yes the road has been cracked, and next this will going to like judge by the brain, yes, how much percentage or what type of crack it is there. So like that it will going to work. That is, I can say, when you look at the cracked road, eye doesn't process
Okay.
the whole image at once. It scans small regions, pick up the edges and textures, and the brain combines these all these signals and recognize it as a yes, it is a alligator crack. Like this, the CNN based classification will going to work. That is a, like again, it's automated as well as a consistent. And again, I can say YOLO, YOLO. That is, I can say the you only look once. I can say it will going to create a yes. We have to again here real time distress location. I can say once the video camera, like if I have images or video cameras, like those images we have to incorporate in the models. It will going to detect the real images, like yes, where the pothole is there or the what type of crack is there. Like these things it will going to detect, and it will going to say that yes, this is what the type of crack. And the semantic segmentations, I can say again the pixel level crack area. I can say it will going to initially the semantic represents that it will going to once it detect the yes crack, and it will going to divide into a number of pixels of the parts, like yes, what type of this like this, yes, and then what it will going to understand, yes, what type of crack it is there, and it will give the yes, it is a pothole or it is alligator cracking or it's a transverse crack or a road surface or it's a background is there. Like this it will going to make the judgment of the evaluation during the evaluation of the pavement surface. And other is the like unmanned aerial vehicles, like or the drone surveys. Usually we are going to conduct it for the large areas with the low cost, and by taking the photographs or the videographs, again we'll come back to this one and again incorporate the model. Like we can use any of the above models. I can say CN based classification or YOLO object detection or segment semantic segmentations. Like this we'll go to incorporate it, so then we can classify it and we'll do the further. Then again we're going to give the ratings for the what type of the payment distress has been occurred. And the other one is the like deep learning PCI estimation. Again, the deep learning, the technique says that the yes, again it's a type of a, like a machine learning only. Again, it requires a lot of like more number of data is required, and again it will take the lot like so many images for the training purposes. I can say that it's a like very objective as well as reproducible things ratings is be very good. So these are the different like traditional methods as well as the AI based inspections methods will be there for the existing payment evaluation. So if I take the AI based, that AI and computer vision techniques, if I take the first one is the CNN, that is a convolutional neural networks. So in this, the first one I have mentioned the AlexNet, VGG, RS. These are all the algorithms or the architectures. So using these architectures or the algorithms, I have to incorporate the images, whatever the images, road images I have taken during the my survey. So those things I have to take it out and I have to load these images in my framework or the like these algorithms, and later these things like again later it will going to run this own model or the how we have trained the model. So then it will going to classify the yes what type of the failure is it is, either it is a alligator crack or a potholes like the payment, I can say the PCI based on the payment PCI values, it will give the what is the rating scales. And the it usually the CNN gives the approximate of like 95% accuracy on the benchmarks of the data set. That is, it depends upon the 95% accuracy, like how much data set, like what type of images we are uploading in the architect or the algorithm. So it depends on the this one. And YOLO is the second one, is the object detection. That is a you only look once framework. That is, I can say the it will like if you run a videograph survey along the pavement, it will only look the pavement surface condition. It will going to make a boundary or the bounding box around it in the real time, and it will judge yes it is a crack hole and it is a crack localization has been formed like this. All these things will automatically detect on its own. And as well as this is method is suitable for the edge or the embedded deployment. And the next one is the semantic segmentation. Again, in this semantic segmentation, there are different architects, I can say algorithms are available: UNet, Deep Labs, SegmentNet, net models. So again, in this, we have to upload the images, like what are the images we have taken during the survey on the pavement, on surface pavement, we have to upload in this. And again, I can say that the again it will mark the pixel level. It will going to initially it will divide the picture into image into number of pixels, and it will detect that the yes this is what the crack area. So based on that area, crack area, it automatically like what are the commands or the how we are done for the coding of the framework. Based on that, it will going to compute and it will say that the yes this is what the percentage of crack or the percentage of pothole or the percentage of this one, up to I can say any per kilometer or per meter, whatever this one. And again it's again the input here we have to automate with the PCI scoring. And the last one is the generative and the self supervised models. Okay, and again GAN based, again I can say that GAN based is the again generative adversarial network based. I can say that this is an advanced version. Here suppose I can say that in this models what they will do, usually if we have like a few images, I can say we have only 10 images or the 20 images, and that is not sufficient for to run the any of the data sets or any of the models in any of the techniques. So what it will do, especially in the generative and the self-supervised models, so here it will going to create its own, there is a synthetic data. So I can say that the raw data it will own creates like a false or the fake data. So I can say the synthetic data it will create on its own along with our raw data, along with the virtual images. It will create its own other synthetic data. So that might be the cracks if it is passing like this, like what are the inputs, how we want, it will create it. And based on that, it will going to again run it the own model. That's what the generative as well the self-supervised models will going to work. As I told, the deep learning, again, so deep learning is an architect. Again, again we can use the first we have to go for the data acquisition, that is using cameras or unmanned variant vehicles or mobile mapping. All these things we can use it. And again, before going for the like next model training, we have to pre-process it. That I can say that we have to remove the noise, as well as the patch extraction. Like we have to extract the other like exact data. What yes, this is what my pothole or the cracks it is there. We have to train we have to incorporate all these images in our model. Okay, the model might be any of your model. You can use the CN model, YOLO model, or the transfer learning. Whatever the other models we want, we can use it. So these models we have to incorporate these images, and next we have to like next it will going to give the like distress detection. That is, I can say the classification as well as segmentation. As I told that If you want, we can go for the semantic segmentation. That is, I can say, yes, it will divide the number of pixels into different form, and it will give the different segmentation. The district detection, yes, this is how the my cracks has been progressed. Or if I take in area wise, yes, this is what the percentage of cracks in a particular area, we can give it. And further, again, we have to incorporate the PCI values. Yes, in the rating of a scale, yes, we have to, this is good, this is bad, that will come up in the next. Okay, so like this we have, and the finally it will give the, based on our PCI values, yes, this is what my road condition is. It is a good or a bad or a severe condition, is like this. Again, for this, what are the type, like how it will work inside. Again, the input we require like a 2048 into pixel, so like a images or the video frame is required. And the framers, I can say the TensorFlow, PyTorch, and these are the, like I can say, models, the machine learning or the techniques. The TensorFlow is usually is provided by the Google, and PyTorch is given by the Meta, and open source like a conventional. This one is again, it's an open source software. These are the framers for to learn the, to carry out our own algorithm like machine learning or this one. And next, the output. The after doing the this framers, we have to incorporate the data input, and output will be the distress type. I can say the severity in percentage. That is the extent. That is a, what is my in the percentage. Yes, this much of percentage of area has been uh, distressed. I can say the pothole has been occurred, the crack, this much of percentage in a per kilometer, per length, or per area, how much we have taken, or how much we have, what are the we have given for the model with respect to that, it will give it to you. Usually we have to follow the, usually we'll follow the IASTM method or the IRC method to give the PCI values. Okay. And next, again, the hardware required to run these models. Again, the GPU server as well as NVIDIA. Just and like these are the advanced, like high-end, like version of like hardwares we require to run these models for that, especially for the deep learning techniques. And next, we'll move to the PCI. So, what do you mean by this? PCI, there is a payment condition index. Okay, so this usually with respect to, like I can say, with respect to ASTM D6433 as well as with respect to IRC, I can define this. It's like a, it will provide a snapshot of the payment health of, it's like I can payment health. Okay, so it is also, it will usually they're going to measure with respect to a, on a scale of 0 to 100. Okay, also may we like other factor also will affect this PCI values. I have given the, like as per the ASTM standards, I have like mentioned the like PCI rating scale. That is, I can say 0 to 10, and 11 to 25, and 26 to 40, 41 to 55, 56 to 70, 71 to 85, 86 to 100. So these scales represents the, like if the scale of 86 to 100 it is good, and again 71 85 it is satisfactory, 56 to 70 it's a fair, 41 to 55 it's a poor, and 26 to 40 it's a very poor, and again 11 to 25 it's a serious series, and 0 to 10 it's a failed. Okay, so this is how the payment rating, the payment condition index, the rating scale has been given by the ASTM standards. Okay, as well as if I go to the, like again IRC code, again it says that the, yes, with respect to the IRI threshold, that is a mm per kilometer, I can say the, for the different road type classification, I can say national highway, state highway, urban roads, or the rural roads, based on the good, fair, or the poor. If I conduct a survey, this much of depth of like rutting or unevenness is there, so then I can say that the, usually they'll go for the IRA represents the unevenness. Okay, road roughness index, yes, this is what the roughness unevenness will be there. So then if it is less than or equal to 1800 to 2400, I can say it's a good, fair, and poor based on the different road types. As well as like IRC, again SP83 like represents the 2008, represents the, like what are the actions we have to take with respect to the PCI scale. If it is a good, no action is needed, and if it is a fair, and again preventive treatment within 2 years is required, and again it is a poor, structural overlay required immediately, and if it is a very poor or failed, full rehabilitation is required. Okay, so these are the different, like I can say the PCI scale, there is a payment condition index scale as per the ASTM standards, as per the IRC standards. And next, what the, how the procedure says, yes, we have to collect the sample unit. I can say that the 230 to 930 meter square of asphalt, like in the particular, if I take an area in a particular stretch of a road, or 20 number of concrete slabs we have to take, and then we have to identify the distress type, that is severity. I can say it may be low, medium, or high, and then we have to plus the quantity, how much quantity we have taken, and then we have to compute this with the compute deducted values from the ASTM standard curves. ASTM has given the standard curves. Along with this, we have to deduct it, and using this CDV corrections will give the PCI, so that I can say the out of 100 scale, so minus the maximum CDV, it will give the PCI, so directly the PCI scale ratings. Yes, this is what my the condition of the pavement. Like this, we have to assess the pavement condition of the existing road. Yes, after assessing this, like I can say these values only we have to give in the AI, the inspection, what we have discussed in earlier, like I can say the deep learning and all. Yes, at the fifth one, you can see in the first, the flow chart, the fifth one represents PCI estimation. That we have to given the input the value of the based on the PCI scale. Yes, this is what my rating scale is, good, bad, or along with the percentage of values. So the distress detection, that the model will work if it is in a scale of, yes, the percentage of severity. I can say that the, yes, it is like 41 which is falls under 41 to 55 percentage. I can say the road is poor condition, or it is falls under like fair, that is a 56 to 70 percentage will use the fair. So again, based on this, I can have to go for the maintenance. Yes, if it is a good, no action required as per IRC, as a fair, preventive treatment, or the poor, I can say the structural overlay is required, or the very poor, I can say the full rehabilitation is required. So this is how the payment condition index will go in, is a plays a major role in the AI, the payment evaluation. So next, as I told, like data sets for the AI implementation, if you are going for the AI implementation in your like techniques, so then what are the data sets we require and the tools and how we have to deploy it. Okay. So the usually the public data sets, I can say the crack forest. The usually the crack forest says the forest represent the, in a forest, if you take the how the trees has been there, like several branches, leaves, and similarly the cracks, if you take any road, the failure, the road which has been failed, if you take the photographs, you can see a lot of cracks will be propagated in different directions. It's like a, looks like a tree with a several branches. Similarly, that's what, based on that they have called a crack forest. So usually, yes, the crack forest again is in like a, it's a very old method. They have taken the 537 crack images and different pixel level masks, and using taking these like images, they are going to use any of the framework like Python 3x or TensorFlow or Polytrack or OpenCV or any of this architect or the algorithm they're going to take, and using these images they were running the models to obtain the PCI values. Similarly, CFD data sets, again it is like a segment, again 118 road tracks they have taken the literature, and again they have taken like again segmented the different data sets, again using the any of the like one framework and the tools like a Python or TensorFlow, whatever the algorithm we can use it, and again we have to map it and we can obtain the PCI values. And again the pothole, again like I can say the, if you take a 600 potholes, again they're taking those images or the videographs, again we have to take this like it's like these are the minimum requirement. I can say that the minimum requirement of the payment images to run the models. I can say if you have the less number of images, we can go for the generative AI model. That is, I can say that we have to generate or develop the synthetic raw data along with our own images, the original images. So I can say that again the pothole, again one of the author they used it, and they have around 600 images, pothole images they have made it, and they run the like again the framework they are used at the tools, and they have obtained the PCI values. And again RD it's a latest one, that is a road data, that is a 22. The reason is a 22 represents the year 2022. So here the 4 countries including India has been contributed for this to develop the this data set. I can say 47,000 images they have collected throughout the including like 4-5 countries. So they have collected these images and they have run the model framework, and they have given the like framed the PCI values based on the scales. And again the crack 500, again the 500 payment cracking images they have taken, and they have run the like again they incorporate the framework and the tools like I can say Python or Polytrack, any of this one framework, and again we can go for the PCI like obtain the evaluate the PCI values. And again, I can say the deployment options, like we can use any of the techniques or the methods to incorporate in the real life. I can say the cloud API is there, edge device is there, mobile apps like GIS integration is there, and the dashboard. Like, so these are the deployment options we can using these data sets. And as well as along with these data sets, we can go for any of the framework using like any of the frameworks, and we can obtain the PCI values. Okay, so these data sets are available. We can say that these data sets are available, so that using these data sets, it will be helpful for all the researchers, those who are like going for research. They can use these data sets for their purpose, because if I take any stretch of a newly constructed road, we can obtain a very few number of images. I can say few number of images, and these images, like how to train these models along with these images, we can take any of these public data sets, like I can say crack forest or CFD data set or pothole or RDD or crack finded. Any of these like data sets, I can take these from the images from these or the data from these. I'm going to incorporate in my own model, and then I'll run my model along with to get the PCI values. So therefore, these data sets they have built to run the model to help the researchers or to develop the any of the framework for to evaluate the payment condition. So these are the different, like I can say, the data sets, tools, and deployment, the options available for the AI integration in the payment distress detection. Okay, and I can say the case studies and the world implementation. I can say, so in the Japan as well as the federal highway as well as state in their own US, like I can say Department of Transportations, they have started like they have implemented the scan the entire stretches of highways, and they started the working using these AI in payment evaluation. Similarly, even in our institute, NIT Arunachal also, I have started along from past 3 months. We have started like using these techniques to evaluate the payment condition in the Arunachal Pradesh, for especially for the national highways as well as the state highways. So again, here I can say I have not mentioned. I have mentioned that like in India, like smart city road monitoring projects. I can say, including the like nowadays some of the municipalities like corporations, they have started like take the photo, upload it, and you will get this one. So because they are creating a public data sets, like if they want the more number of data to run a model, so that the AI can automatically run further, and it has to rate the scale on its own, like PCI values. Yes, this much amount of like the payment has been deteriorated, like that. So that nowadays it has been started in India also. So again, in Netherlands, AI for the infrastructures, I can say the drone based highways surface mapping, again deep learning methods, that all these methods they have incorporated in the other countries also. In India also, a lot of like all the IITs and NITs as well as other institutes, the private organization also, they have started. So do the research on this as well as to implement these AI in the payment evaluation. Next, so what are the major current challenges in this, like existing current challenges, especially to incorporate this techniques, that I can say the data scarcity. First thing is the data. So how much the data is required, like that is a very scarce. Like I can say the availability of the data is very limited, and again it's a imbalance. I can say that it's not a balance. Again, it's a rare distress type. I'm going to get it. So again, the environmental variability. I can say that the lightning, shadows, wet surface, this will going to affect the accuracy of the PCI values. I can say output values. Again, the domain shift, or the models trained in one region and the fail in another region. I can say that yes, if I take that, since as I told in the initial, the roads has been constructed throughout the world within, and it has passed in the different region. I can say plains, mountains, hilly terrains, different terrain condition. I can say that what are the images they have taken in the plain terrain, it may not work in the hilly terrains, because here the gradients of the road is everywhere. The gradient they have maintained is 7 to 8%, especially in the worst cases. Okay, sometimes they have gone for the exceptional gradient also. Again, the payment distress type in these hilly regions also very difficult, especially I can say the domain shift. Again, the data will not going to much. I can say it's a variable imbalance. And again, the real-time processing, that I can say heavy models need the optimized inference pipelines. That is, I can say the very best, I can say deep learning, the real-time processing. Yes, today what is the updated portion? Yes, this is what the existing now, this type of crack has been occurred. Yes, go to it again. based on that crack, again the evaluating the PCI value, again it is a challenging one. And the standardization gap, there is no universal AI based PCI standard adopted yet. That is a throughout the world, like different peoples, they are using the different techniques or methods to evaluate the like payment distress or the evaluation, but still like yes, we are lagging in this standardization the gap. So these are the current challenges. If you take like any one of these, like again if you want to work, there are a lot of like scope for the further research, for especially for the faculties. And from this I can say that the so these are the current challenges. As a, this if you overcome these challenges, it become a very good research gap for the researchers. And the opportunities for the participants, and using this whatever that's like I can say given this topic, so I can say the for the MTech and PhD topic also you can use it for the AI based automated PSCI estimation for Indian roads, as well as I can say the lightweight CNN models for the edge deployment. We can adopt this because we are lagging the data sets, especially in our country. As well as I can say the multi-class distress detection using transformers models also we can give for the MTech or the PhD topics. And again, the weather invariant crack segmentation network is also one of the problem in this area, that also we can give it for the MTech or the PhD topics. And again, if I go to further, like I can say the curriculum integration, like if you want, like you can add it for your undergraduate or the MTech level curriculum. Yes, you can use it as a AI in Siemens as a new elective course, and again you can go for the lab exercise. I can say for especially for this payment evaluation, like crack detection using any of the architect. Here I have mentioned the OpenCV or the algorithm, I can say. And you can give the hands-on like transfer of learning of the road images. You ask the students like yes, you take any one of the stretches near to you, you take those road stretches and carry out the like take the images or the take the videograph surveys, and you can convert these images and put it in any of the architect. I can say that the CNN or the YO YOLO or any of the advanced like generative AI based models, and you can ask them to run it. And so they'll get the hands-on experience on this, and you can give the student project also. So like this, you can add it in your curriculum of your own like universities or the colleges. And again, along with this, like I can say the industry linkages. Yes, we are lagging with the industry linkages along with the academia. We can go for the like with the MOE with the I have mentioned only one or two government sectors here. Other government sectors also there. If you want, like you could in, like interested in like for the startup, I can go for the road AI analytics platform. In this platform, there are a lot of scope is there for the future for the road evaluation methods. Okay, so from this, I'm going to conclude my this one. The summary of this like presentation, like we have discussed like a payment distress, the problem. Yes, this is how what are the problems will be there like after the construction of the road, after like 1 or 2 years because of traffic as well as the environmental loading, the payment will be subject to different deterioration or the distress. Yes, after distress, yes, we should not keep quiet. If we keep quiet, again, what are the like rehabilitation or the overall overlay cost will going to further increases. So therefore, before that, we have to go for the payment evaluation. Yes, what its condition with respect to the PCI values. It is a good, fair, or a poor, or a fail. Like that, we have to evaluate with respect to the PCI values with respect to percentage. So in this earlier, like we have discussed, like a traditional method as well as the AI inspection. Yes, for the AI inspection also, it requires again the images. Okay, so it's like I can say that it's objective oriented. So that's also we discussed here. Yes. After next is the core AI techniques. I can say the different techniques we have discussed. I can say that the CNN model or the YOLO, other like and again schematic segmentation as well as the generative adaptive based models. So these techniques we can adopt as well as the deep learning architecture we can adopt, so to evaluate the existing road surface condition. And along with this, like we have to after evaluating, like we have to map with the existing IRC or the ESTM standards that also we discussed, as well as the research and the deployment path already. These are things we have discussed in the in our topic. Okay, so from this I'm going to thank you, and these are my references. Okay, thank you, thank you all. I'll take up some questions and discussions if you are having any.
Yes. Um, Dear participants, if you have any questions, you are welcome to unmute yourself and ask. The
Yes, Professor.
platform.
May I go ahead, Professor?
Yes, sir. Yes, sir. Please, sir.
Yeah, very nice presentation, Professor. So, as I understand, the AI is being used if there is a old road identification of that particular highway or the payment,
Yes,
and
sir.
then repairing using AI techniques.
Yes,
This
sir.
is what is the thing.
Yes,
Now,
sir.
I'm if you allow me to tell,
Yes,
going
sir.
further,
Yes,
if
sir.
this particular intelligence is embedded into the newly constructing roads, so
Yes,
we
sir.
already and the precautions to be taken while in the operation also,
Okay, sir.
will that be more meaningful, sir? Did
Yes,
I
sir.
make some sense, sir?
Yes, sir. Yes, sir. Yes, sir. Good. Yes, sir. Sir, one this one in especially I can say that in our like country. Yes, as you told, we are going to incorporate all those like I can say sensors or the some other like inside like before the construction or during the construction, like later stage now getting those datas or the maintaining the datas or collecting those datas. It requires some of the manpowers or requires some like that maintenance is not there. We are lagging there actually.
Sir, sorry to interrupt you. I'm not
Hmm.
talking about the data itself.
But yes, sir,
Um,
like as you told, like that's what I can say. Like we can incorporate it and we have to get the raw data from there. Now, like who is going to take those datas, take care of this those datas?
Sir,
Huh.
example, if you allow me to tell, example, if at all person is having a problem with the lungs, the
Yes, sir.
you know that there is a solution, but for
Yes, sir.
other healthy man, we can always suggest the breathing exercise is the better to avoid it, right, sir? So like
Yes, sir.
that, what I'm trying to, I don't know what am I
Yes, sir.
communicating to you
I
properly?
understood your question. Yes, that is fine, sir. But like as I'm putting in other way, like yes, we can incorporate these things. But as I told, like maintenance again, the maintenance will be there. That's what my
Sir,
this. But as you
in
told, that
fact,
is a good suggestion.
yeah, yeah.
Uh,
In fact, for maintenance also,
yes, sir.
see, these are all we are at the fantastic material stage.
Yes, sir.
Even the maintenance also,
Yes, sir.
we can try to see that there is a self healing mechanism. That's what I was just thinking. I'm thinking
Okay, sir. Okay.
theoretically. I'm sorry,
Yes,
I'm not very well. I'm not an expert in this payment, nor
it's
an
okay, sir.
expert in AI. I am
Yes,
just
sir.
as a layman. I'm just thinking that even that there are healing concretes, if I'm not wrong, sir, self
Yes,
healing
sir.
concretes.
Yes.
So self healing materials, if at all we can utilize how much it has to be used and all that, if that AI can help us out,
Yes,
because
sir.
as you know, it will be very easy. That's what I understand, sir. I'm sorry if I'm asking a
Yes, yes, yes. Correct, sir. Correct.
layman's question.
Yes, yes. No, 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 sir. As you told, correct. I accept.
Yeah, is there a way to do that, sir?
Yes, sir. Sir, we can go at sir like that. Also, we can go.
I mean, anyone attempted?
No, sir. Actually, that's what like I can say that everyone is we are failing there actually. Like after like incorporating those things, like how it works because our environmental condition also like adverse. I can say we don't know when is the like how much amount of rainfall will be there. Or example, I can say landslide will be there. Like again, I can say self healing, as you told, self healing materials. Like up to what term? Like if it is beyond the threshold, then what will happen? So whether it will not going to heal, what will do?
I think everything. I mean, in a due course. I am not
Yes,
asking
sir.
now
Yes, yes,
only.
yes, 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 sir. Yes, sir.
Now,
As you
now at all, if at all, people might have been doing also. Now, if you
correct, correct,
start,
correct. Yes,
I mean, down the line, 5 years or 10 years down the line, we get only once you lay the payment or the road or the highway, and that's it.
yes, sir.
There
Yes,
is
yes,
no, not even sensing is required, not even anything is required. The human being can live up to 120, 25 years.
yes, sir. Yes, yes,
Similarly, it be done using AI. That's
yes,
what
sir.
I.
Yes, sir.
Sorry if
Yes,
I'm
sir.
asking you a layman question
No,
and
no, sir. No, 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 no.
non-expert question.
Yes, sir. No, sir. No. It's okay, sir.
Thank you, sir. Thank you
Thank you,
for
sir.
your nice hearing, sir. And another question I was trying to ask,
Yes,
in
sir.
your slide number 8, you were talking about you generated the synthetic data. Slide
Generating a
number 8.
self-supervised model, sir.
Yeah, here you are mentioning you generated a synthetic data. That's what, if I remember correctly.
Yes, sir.
But
Correct,
in
sir. Correct.
slide number 11, you were telling that there are 47,000 data sets available.
Yes, sir.
I mean, this 47,000 data sets, can it be used to this, or this is
Yes,
the,
sir. Yes,
yeah,
sir.
that is
Sir.
what I was just trying to ponder over it.
Yes, sir. Sir, that's what I want to say. These are the now they have made like it's a, in 2022 they have made this research, and they have collected a 47,000 images. So like these data sets, it's the public available. We can use these data. Still, if you are not getting those data, if we have only few datas, then that's what I told, we can go for this like a generative and self-supervised models. So we have only few datas, I can say 10 or 20 data sets. So it will going to generate a synthetic datas on its own. But if you have sufficient data, that is there is no issues. You can do it in this using this.
So there the human intervention is required, or AI will help us out.
So there AI will do this one.
AI will automatically say the existing data. It will check it up. If that is
Yes, sir.
not
Yes, sir.
there, then it
We
will.
along with sir, along with our like whatever the images, existing road conditions. Suppose now these data, those images they have developed in 2022. So now in 2026, suppose today we have taken some road images like 2030 road, like 30 to 40 number of pics. So those pics, if you incorporate this one, and you can use those images also in this, so it will going to run and it will give the PCI value for you directly.
But there are a lot of linear models or the interpolation models now, sir, so that it can also, without generating the synthetic data, is there
Huh.
a way to generate the data from the available data
Oh,
with,
yes,
with
sir.
of course, interpolations and numerical techniques?
Yes, sir. That we can go, sir. But like, sir, as per my knowledge, I can say for to run any of the this one like a framework or the machine learning or any
Okay.
algorithm, it requires a minimum number of data sets.
Okay, sir. Thank you, sir. Thank you. Very
Yes.
nice of you, sir.
Thank you, sir.
Thank you, sir.
Yes,
Any
ma'am.
other questions? Thank you, sir, for that highly informative and engaging session. Your insights into AI-based pavement, distress detection, and condition assessment have truly enhanced our understanding of modern approaches in infrastructure management. Your perspectives added great value to the session and gave us all plenty to reflect on. We truly appreciate the time and effort you took to share your knowledge and experiences with us. Now, to conclude today's session, I would like to invite Mr. Sriram Mustapure, Assistant Professor, Department of Civil Engineering, to propose the vote of thanks.
Good morning, everyone. Myself, Sriram Mustapure, Assistant Professor, Department of Civil Engineering, Sir MVIT. It's my honor to propose the vote of thanks for today's session. First, my sincere gratitude to the management, principal, vice principal, and HOD and department faculty coordinators for the constant support in organizing this enriching session. I'm deeply thankful to our esteemed speaker, Dr. Jaikesh Sir, a distinguished alumnus of the Sarim VIT and academician and researcher, especially your clear comparison of conventional and AI models and the pavement condition index with IRC norms and the datasets, tools, and development approaches for AI. Your holistic view of AI in civil engineering and your logical problem driven explanation made session truly engaging. Thanks also to media publicity team. Finally, I appreciate all participants for your active involvement and enthusiasm. It was made event all the more meaningful. Thank you one and all.
Thank you, all. Thank you so much.
Thank you.
Thank you. Thank you.
Thanks to everyone for joining this session. The feedback link has been posted in the chat box. Kindly fill it for the session. Thank you.